We just saw that g, that is acceleration due to anything, right? Anything is given by g into mass of that particular thing divided by radius of that thing. Okay, so we saw it as earth, but it's in general, this is the expression of acceleration due to gravity because of something. So we're taking up two cases. One is that of near the surface of the earth, and the second one is near the surface of the moon, right? So these are your required values that we need to make a note of, and we should start calculating. So let's figure out for the case 1 near the surface of the earth. So acceleration due to gravity near the surface of the earth is g into m of earth divided by radius of the earth square. So this would be equal to 6.7 into 10 to the power of minus 11 into mass of the earth is 6 into 10 to the power of 24 divided by 6.4 into 10 to the power of 6 the whole square. So this would be equal to 6.7 into 6. I'm getting all the numbers at one end. 6.4 into 6.4 into 10 to the power of minus 11 into 10 to the power of 24 divided by 10 to the power of 12. Agree? Right, guys? And now on to calculating with the calculator. 6.7 into 6 divided by 6.4 divided by 6.4. 0.98. It looks familiar. 0.98 into 10 to the power of minus 11 plus 24 plus 12. Oh, sorry, minus 12. So minus 12 minus 11 is minus 23 plus 24 is 10. I mean 1. 10 to the power of 1 is 10. So this is 9.8 meter per second. And this is the value which we saw. Right? And this is how we can calculate it. Experimentally saw it was 6.7. Actual value is 9.8, not 6.7, sorry, 9.7, and actual value is 9.8. Approximately for calculation we can take it as 10 meter per second square. Okay, right, let's move on to the next thing, that is calculating acceleration due to gravity on the surface of the moon. It's equal to g mass of the moon and radius of the moon. Okay, guys, so the values are, I have the values. So this is 6.7 into 10 to the power of minus 11 into, you guys can also do it, these are the values, right? This though you guys know, you guys can figure out on the surface of the moon what is the acceleration due to gravity. You can pause and please try it out. You can use calculator, it will hardly take 2-3 minutes. Okay, I hope you guys have tried. So mass of the moon is this, and radius of the moon is 1.74 into 10 to the power of 6 the whole square. So let's get all the numbers at one end, right, and let's get the exponent part at the other end. 10 to the power of 12. Okay, now on to putting them, okay, putting them together. We have 6.7 into 7.35 divided by 1.74 divided by 1.74, and we have 16.3 approximately 16.3 into 10 to the power of minus 11 plus 22 minus 12, and this will be 10 to the power of minus 1, right? So all of this is minus 1, and 10 to the power of minus 1 is divided by 10 basically. So 16.3 divided by 10 is 1.63. So you can see the value is so small. What does it mean? Well, the effect of this you can see practically. Well, we can't do it practically. Maybe some point of time some of you might be able to. That would be fun. Right, let's compare it that of the earth so that we understand this value. So 1.63 divided by 9.8. So we can 163 by 980. Right, I just multiply and divide with 100. I want it in the form of a fraction, so I'll divide 980 by 163. So you can clearly say it's 1/6. 1/6. What does it mean? Acceleration due to gravity on the surface of the moon is 1/6 that of the earth. In comparison to earth, it's 1/6. That is, whatever weighs, like say something weighs 60 kg on the surface of the moon, it will be just, I mean, you will feel like if it's as if it's 10 kg. Feeling is different. Remember, mass is different, weight is different. If you guys don't understand this, we have a separate topic for this. We'll be learning about that. But you need to understand what does this value mean, right? To make a sense out of this, okay? So this is important. So to make a sense out of this particular value, what you guys can do is do this web search. So go and look into say moonwalk, not the dance, but the actual moonwalk. Okay, so what is the point of watching that? Well, you guys need to understand what is the mass of the spacesuit. Okay, spacesuit's mass, and the people who walked on the moon, their mass as well, a person's mass. So multiply that with 10. This would be the weight of this combination of these two. And practically think about how practical it is for a person to walk freely on the surface of the earth. If they found, I mean, if it's not practical, but how is that they did it on the surface of the moon? You know, how did they walk on the surface of the moon? You can see them kind of jumping around, not exactly like fully jumping. That would be not advisable on the surface of the moon. So they'll be just jumping around, and they stumble and they get up as if there's nothing. See, they're carrying a suit, and that suit, of course, it weighs something, is it not? The person himself, the astronaut himself, has some weight. Put together, the weight of this entire thing will be pretty decently heavy for a person. But they were able to walk freely on the surface of the moon. Okay, that's the first question you guys should be asking. And you should be asking questions like, see, those people who are on the surface, who went to the surface of the moon, did they come back? They did, right? But for any person to escape the gravitational pull, like say on the surface of the earth, what did they do? They had to have a rocket in which they sat and they booster rockets and all of that, and you know, to this were attached the I don't know, the plane. We call it plane. I don't know if we call it as plane. Anyways, the plane basically. And this is pretty big, you know, launching all of this and all of that. But on the surface of the moon, was there already rockets like this so that they could sit in this and the launching happened? So basically, you should be asking, how did they come back home? You know, because think practically, how is it possible? Matlab, we have such a huge rocket that to launch from the surface of the earth, right? But same setup, I don't think we had it over there, because all of this falls off to the surface, back to the surface of the earth. You know, right? How the rocket launch happens. Not all of this goes out of space. Either the satellite, if not, in this case, the space shuttle. Yeah, space shuttle. It's not plane, it's a space shuttle. So space shuttle, they go out of the space. Matlab, at least out of the exosphere and all of that. But not the entire thing. So how is that they were able to come back? Right? How much energy did they need? This is what you guys have to think over, pose this question and research, you know. So people who are interested, there's a lot of opportunity out there to learn, because everything is there on net, right? If you want to learn anything, understand anything, it's there. Okay, you guys are in a good era to learn things, so please do make use of all such resources. Okay guys, so let's recap one important thing. All of this calculation and all of this made sense because of the fact that acceleration exerted by an object is independent of its mass. All of this value is applicable to everything that is there. That is, if you take any a feather, and if you take a ball, if you guys let them in outer space, right, wherein there is no vacuum but there is gravitational pull, what happens? They will fall at the same time. Matlab, they'll reach the ground exactly at the same time. This means that all objects, whatever it may be, they fall at the same rate. Okay guys, so this is an important conclusion. And from this slide, I would like you guys to talk to your teachers and check if you guys have to memorize these two values. Okay, this calculation is something that you guys, it's not too difficult. This formula is what you guys have to first derive, and if they ask you to calculate the value, I'm pretty sure that this is given by them, in the answer script. If not, well, you can ask your teachers. Basically, you ask your teachers whatever it is, then you guys have to end up with this particular value. It's not that difficult of calculation because you guys know the answer already. Just write all of this expression, write this, you're done. Right guys, this is not for exam, not meant for exam, not for exam. Okay, let me write for itself, not for exam. So this is only for curiosity, right? So we get to research all of this, but yes, this conclusion is for exam, that whatever you'll understand when I do mass and weight, you'll understand this value. But yes, how we got this value, that we do get this value, is what you guys need to understand over here. So do write it. Okay, and yes, this is, I would request all of you guys to research this. It'll hardly take, it's better than watching, well, anything on the TV. This is interesting. Sit with your friends and do this. It'll be fun to discuss. Okay guys, and yes, this you guys have already written. Okay, so pause and write this as well.